Hi dear students, good morning to all. Dear students, in the previous part of the video, we have studied a various concepts in the chemical kinetics like rate law, rate of reactions, order of reaction, and the molecularity of reaction. Dear friends, in the previous part, we particularly studied about the rate law, order of reaction, and the molecularity of reaction. We also tried to distinguish between the order and the molecularity of reaction with the help of different examples. Dear friends, today in this part of the video, we are going to study about the first order reaction, because in the last part we have studied how we can calculate or how we can determine the order of reaction, which is one of the important experimentally determined quantity, depends upon the slow step of the reaction, and based upon the order of reaction, the reaction can be classified into various types. If the order of reaction is 1, then the reaction is called as the first order reaction. So, dear friends, today in this part of the video, we are going to study about the first order reaction and the equation for the rate constant of first order reaction. First of all, we should know what is first order reaction. Here, it is the first order reaction. It means that the rate of reaction here depends upon the molar concentration of only one reactant. That's why it is called as first order reaction, because already whenever when we studied about the order of reaction, then we stated that the order of reaction is the number of reactant molecules on which the rate of reaction depends, and if the rate of reaction depends upon only one reactant molecule, then the order of reaction will be 1 and it will be called as first order reaction. That's why the first order reaction can be defined as the reaction whose rate of reaction is directly proportional to the molar concentration or the concentration of only one reacting substance in the chemical reaction. Then the reaction is called as first order reaction. For that purpose, suppose we will consider the general reaction in which A is the reactant, B is the product. Then the rate of this reaction can be written as minus dCA by dt is equal to K into concentration raised to 1, and this 1 indicates this is the power or the exponents of molar concentration of reactant in the rate equation, and this power in the rate equation or this power of the molar concentration of reactant in the rate equation is called as order of reaction, and that's why here order of reaction is equal to 1. Here C is the concentration of reactant A and K is proportionality constant here in this equation, and this constant or this proportionality constant K is called as specific reaction rate, or it is also called as the velocity constant. Dear friends, from this equation we can conclude that, or we can say that whenever this concentration of the reactant in this equation is unity, then this rate of reaction simply equal to the specific reaction rate or the velocity constant. So here, whenever the concentration is unity, then the specific reaction rate or the velocity constant is always equal to the rate of reaction. That's why whenever you want to define the specific reaction rate or the velocity constant, then it can be defined with the condition the concentration of the reacting substance in this reaction is unity, and hence the specific reaction rate or the velocity constant is defined as the rate of reaction when the concentration of the reactants is unity, and hence reaction rate at any instant is equal to what? Reaction rate, this minus dC by dt is the reaction rate, is equal to what? Product of this specific reaction rate and the concentration of reactant. That's why rate of reaction at any instant is equal to the product of specific reaction rate and the concentration of reactant at that instant. So here this is just about the first order reaction, how we can write the equation for the rate of reaction for a first order reaction in which the rate of reaction depends upon only one reacting substance. So now we will discuss how we can derive the equation for the rate constant of first order reaction. For that purpose, we will consider the same reaction in which A is the reactant, that A will be converted into product. Suppose here we will consider small a is the molar concentration, initial molar concentration of the reacting substance, and small x is the amount of reactant reacted or the amount of product formed in a particular time or in a time small t. Then the amount of reactant remaining out of A, X is reacted, X is product formed. So therefore amount of reactant remaining left unreacted will be A minus X after time t, because out of A, X is reacted, that's why remaining left unreacted will be A minus X. So this A minus X is the concentration of reactant left unreacted after time t. That's why this rate of reaction dx by dt, dx is the x is the concentration of product, it goes on increasing, that's why it has the positive sign. No sign indicates positive sign. Therefore dx by dt is directly proportional, means dx by dt is the rate of reaction is directly proportional to the concentration of reactant at that instant. And what is that concentration? A minus x. We will remove this propriety sign, therefore we will get the equation dx by dt is equal to k into A minus x. Here, in order to determine the value of velocity constant, this k, this equation can be rearranged, in which we will separate the terms of x on one side and the terms of t, time, on another side, and we will integrate this equation. This is called as integration. So integration of dx upon a minus x is equal to k into integration of dt. So the integration of dx upon integration of this term dx upon a minus x will be minus ln of integration of this term will be in the mathematics minus ln of a minus x. Remember that. While the integration of dt, this term will be only small t. How it comes here, so you can see here the integration of dx upon a minus x will be minus ln of a minus x, and integration of dt will be only t, therefore it is k into t plus constant of integration because it is without limit. We not find the value of this constant of integration k prime. We will use the condition when time t is equal to 0, no product formed because no reaction started at time t is equal to 0. That's why the value of x will be 0. If we will put the t is equal to 0 and x is equal to 0 in this equation, then we will simply get minus ln of a is equal to k prime. If we will put this equation in this equation, definitely we will get this equation minus ln of a minus x is equal to k into t minus, instead of k prime there will be minus ln of a. Now I will transfer this minus ln of a on this side, so it will become this ln of a minus this term ln of a minus x is equal to k into t. Dear friend, this is simplification in the mathematics. Ln of a minus ln of b is always equal to ln of a upon b. Remember that. So ln of small a minus ln of a minus x. So this small a is considered as the capital A and a minus x is treated as b. So it will be simplified as ln of a upon b means ln of a upon a minus x is equal to k into t. Here we can convert this natural log to the log to the base 10 by multiplying 8 2.303. So whenever we want to convert the natural log to the base 10, we have to multiply by 2.303. Therefore this it should be 2.303. It should be 2.303, not 2303. 2.303 log to the base 10 of a upon a minus x divided by a minus x is equal to k into t. Now we will write the equation for this k, velocity constant of the specific reaction rate of first order reaction, k is equal to 2.303. This t will be divided to this 2.303 upon t log to the base 10 of upon a minus x, and this equation is called as the equation for the kinetics of first order reaction, or integrated rate equation for a first order reaction. This equation can be also integrated with the limits of concentration, initial concentration C0 and concentration after time t is C. Then we will get the simplification of this equation, or the as ln of C0 upon C, means the initial concentration to the concentration after some time k into t. Therefore it should be 1, not L. Therefore k is equal to 1 upon t into ln of C0 upon C, where this C0 is the initial concentration of reactant at time t is equal to 0, and C is the concentration of reactant after some time t. So again we can convert this natural log to the base 10 by multiplying 2.303, and we will simply get this k is equal to 2.303 upon t log to the base 10 of C0 upon C. So this is very simple to discuss about the equation for first order reaction, or to discuss about the first order reaction and the equation for the rate constant of first order reaction, or the velocity constant of first order reaction, which can be used to determine the rate of first order reaction. So dear friends, in this part of the video we try to study about the first order reaction, and in the next part of the video we will try to study about the characteristic of first order reactions. So we will resume in the next part of the video to study about the various characteristics of first order reactions. Thank you very much.